Hey everyone, here's a video on converting exponents to radicals. We're going to start off really basic with using just numbers, and then we're going to move into using actual variables. Okay, so the first thing you need to know is the definition of a to the 1 over n. So if n is a positive integer that is greater than 1, and the nth root of a is a real number, then a to the 1 over n is equal to the nth root of a. Okay, so the way you define it, so you have a to the m over n, where m is your power and n is your index. Then we say it's the nth root of a to the m. And to help you remember which way it goes, or how to set up your radical, is we talked about the burger place, which a lot of y'all said is really great in California and in Dallas, the in and out. So your power, which is your m, goes in, and then your n, which is your index, goes out. So as you can see here, your power, which is our m, this goes in, which you can see right here, and then your index goes out, which you can see right there. Okay, so our first example, we have b to the 1/2. Our power is 1, and then our index is 2. So if we were to use our in and out, we'll have b to the 1 on the inside and 2, which is our index, on the outside. Now the cool thing about this is we don't have to write something to the first power, since something to the first power is always itself. And then also, a radical with no index always represents the number 2, because instead of saying we're taking the second root, we say we're taking the square root, which is stuff we already discussed before. So this is equal to the square root of b. Alright, so we're going to start off with two examples. So we have 8 to the 1/3 power. So for the 1/3 power, our power is 1, and our index is 3. So if I were to write this in radical form, I have 8 on the inside. My index is 3, so that's on the out. And my power is 1, so that's on the in. But as we literally just stated, you don't have to write something to the first power. So what I'm asking you to do is take the cubed root of 8. Okay, and the way you would do this using the chart that Mr. Talent copied off for you is you would look to where it says power of 3, then go down that column until you find the answer 8, and go over to the base and see what the answer would be. And this would be equal to 2. Since 2 cubed, ooh, this is awkward, sorry. Oh, my pencil messed up. I'm so sorry about that. So 2 cubed is equal to 8. So the cubed root and the cubed function undo each other, just like the square and the square root. Now the next one. We have 81 to the 1/2 power. So our power is 1, and our index is 2. So this is saying that we're going to take, the 1 goes on the inside, because it's your power, and your 2 goes on the outside. But as we just discussed, you don't have to write the 2 on the square root, and you don't have to write the 1. So this is asking for the square root of 81, which is a perfect square, and we know that's equal to 9. Okay, our next example, we have 81 to the 1/4. This one, our power is 1, and our root, or index, is 4. So writing it in radical form, we have the 4 on the outside as our index, and I'm not going to write the 1, because we know that we don't have to write anything to the first power. So what I'm asking you to do is take the 4th root of 81. So for those of you that are using your calculator, you'll type in 81, put a caret, which is above the division bar, parenthesis, 1 divided by 4, and close your parentheses. And when you do that, you get the answer of 3. So the fourth root of 81 is equal to 3. Okay, next one. We got 8 to the 2/3. Excuse me. Okay, so our power is 2 because it's on top. And then our index is 3. Ooh, my pen is acting weird. I'm so sorry. Alright, so writing it in radical form. 8 goes on the inside along with the power. It's a power of 2. And index of 3. Alright, for those using the calculator, you type in 8, put a caret, parenthesis, 2, divided by 3, close parentheses, hit enter, you get an answer. For those of you solving it by hand, we're gonna go ahead and square 8. So I 8 and I 8 till I got sick on the floor. So 8 squared is 64. And now we gotta take the cubed root of that. And when we do that, we get that it's equal to 4. Alright, next one. 16 to the negative 1/2. What's different about this one is the power of negative 1. So our power equals negative 1, and our index equals 2. So writing it in radical form, I'm not going to write the index of 2 because we know the radical by itself is the square root. So I have 16 to the negative 1. Okay, so we have a negative exponent, so we got to imagine that that's in the numerator. So since this is negative, all of this has to go to the denominator. So this is equal to the square root of 1 over 16. And when you take the square root of a fraction, you take the square root of the top, so square root of 1, over the bottom, so square root of 16. The square root of 1 is 1, square root of 16 is 4. So your answer is 1/4. For those of you using the calculator, you hit 16, caret, negative 1 divided by 4, or 2, sorry, my bad. Go back. Okay, divided by 2. And then you'll end up getting 0.25, which is equal to 1/4. So you are on the right track and everything's going great. Alright, the next thing. So that was really basic. We're strictly just using numbers. Now I'm asking, is it possible to simplify a variable in radical form? And of course, the answer is going to be yes, you can. Alright, so next thing, what does the index tell you? So the index is going to tell you how many in a group you need to take out one variable. So for example, for the square root function of x, so for instance, say we have the square root of 25. You know 25 is 5 times 5. So we got 5 times 5. And it has an index of 2. So what I'm saying is you had to have 2 5s in order to take one out, because we know the square root of 25 is equal to 5. So you had to have 2 on the inside to take one out. So the index tells you how many you need to have on the inside in order to take one out. So your first example, we have x to the 6/4. Your power is 6 and your index is 4. So if I write it in radical form, I have the fourth root of x to the 6. Now I'm going to expand out x to the 6. So x to the 6 is x times itself 6 times, as you can see. Now, since my index is equal to 4, I need groups of 4 in order to take one out. So since I have a group of 4, I was able to take out 1x. Then I had 2 left off on the inside, and x times x is x squared. So that remains under the radical. Alright, so for first example, we got x to the 8/3. I'm going to go ahead and go straight into writing this in radical form, because by now you should understand how to do it. If not, feel free to go ahead and pause this video and go back and relearn it. So we're going to take the cubed root of x to the 8th power. So that means I need to write out x times itself 8 times. So I have 1, 2, 3, 4, 5, 6, 7, 8. Okay. Alright, now my index is 3. So that means I need to have groups of 3. So my first group is right here. Then I have another group right here. Then I have 2 left off. So this first group right here is going to take an x out. So these are gone. Then my second group right here is going to take out another group, another x. So those are gone. Then left under my radical. So I have 3, I have x times x, which we know is x squared. Alright, now I need to multiply my x times x on the outside. X times x is x squared. Then I have the cubed root of x squared. My final answer is x squared cubed root of x squared. Alright, next one. I got x to the 7/4. So writing this in radical form, I'm taking the 4th root of x to the 7th, which means that I need to write x times itself 7 times. So 1, 2, 3, 4, 5, 6, 7. Okay, since my index is 4, I need groups of 4. So I got 1, 2, 3, 4 right here, and I have 3 left off. So this means I have one group of 4. So 1x is going to come out. Then I still have the 4th root, and I have 3 x's on the inside. So x times x times x is equal to x cubed. So x times the 4th root of x cubed. Alright, next one. I got x to the 9/4. Sorry. So writing this in radical form, I will have 4 on the outside, because that's my index, to the 9th power. So this is equal to the 4th root of x times itself 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, need groups of 4. So I have 1, 2, 3, 4. There's a group. Then 1, 2, 3, 4. There's a group, and I have 1 left off. So that means I'm going to have about 1x times another x. So that makes x squared, because x times x is x squared. Then I have the 4th root of x to the 1st power. That is my final answer. Okay, last one. I got x to the 5/2. So there's 2 different ways I can write this in radical form. I can write this as with a 2 on the outside, with x to the 5th on the inside, or I could write this as the square root of x to the 5th, which is totally fine. Alright, so now writing this in expanded form. I'm going to write my index so you can see how many we need in a group. I gotta have 5 x's. So 1, 2, 3, 4, 5. Alright, now I need groups of 2. So 1, 2, 1, 2. So I have 2 groups of 2. So I'm going to take out 2 x's. So x times x is x squared. And then I have the square root of x as my final answer. So x squared, square root of x. Okay, I know the last little part was kind of fast because I'm running out of time. Make sure that if you're confused at any point that you pause it, go back, rewatch this as many times as you need to. Do whatever you need to do in order to make sure you understand this stuff. Feel free to ask your teachers, or you can come ask me. It doesn't matter. I'll answer your questions. But I hope this helped. Have a great night.